Good morning, dear colleagues. My name is Vasily Puchkov, and this is the beginning of our morning session, and the first presentation will be delivered by Vasily Puchkov, and he will be talking about Postgres database operational experience in an enterprise-level network. Hello, I am Vasily Puchkov, and I am head of databases department in so-called 1S basis in TSK company, which is an IT part of Gazprom Neft. Basis is what Droshkevich was talking about when we have specially trained people to maintain 1S servers. They are not dealing with configuration or administrating, they are just maintaining 1S databases. We have special people for it. So what is our technology center? As you can see, we've got 33,000 users, 4 time zones, 15 cities, 500 informational bases, more than almost 400 1S people. Of course, this brings certain liabilities, certain special things of how to maintain this all, because volumes are massive. We've got a lot of databases, but at the moment, out of these 500 databases, we've got around 50 Postgres databases. So last year it was less than 50, now we've got almost 100 databases. So step by step we're moving towards increasing Postgres database number. So what are the main key feature of this big corporate network? So number one is information security. So it's our top priority. It goes before fault tolerance. So everything must be secured. And second, if, for example, our security guys say no to this kind of solution, it means no. No matter how brilliant it is, if they say no, it means no. No go. Second is fault tolerance. Because you understand the scale, you understand the budget, you understand the cost of downtime. Because we cannot stop loading oil barrels just because our server is down. So the consequences for business will be drastic. And of course, compliance with corporate standards. Why? Because our company is big. We've got a lot of databases. We must ensure that our people can be easily substituted. And it's not just about competence. It's when a person goes to a server for the first time, they should understand how this was fine-tuned. And in fact, this thing is quite important for cooperation. If there are any people from enterprise, you must be aware of it. But if you are going to integrate such solutions, please take this into account. Because the work will be sped up, cost of labor will go down. And if, for example, you've got a server that works fine for a couple of months, but then it crashes, it goes down. So without any logs, without any documentation, you should know what was exactly set up and how. So what about information security? We've got roles, standard Postgres roles, so no need to tell you about this. A very good mechanism that allows you to implement everything you need. PGConf. This is the file that some people ignore, or not just ignore, they just negligent about it. They set up for one time and they leave it aside. But actually it allows you to configure security settings in a very decent way, and also we're using Kerberos for security features. By design it is the most robust solution, the most reliable, that ensures the high security level. It allows you to protect the system from unauthorized access, and also it protects the server. 1 year ago I was talking about this in detail, so there is no need to mention this once again. And this should be multiplied by proper design. So your architecture must be correct, because the best tool that you may have is absolutely senseless if you don't know how to use it.
Соответственно, да, PGHBA это, грубо говоря,
PGHBA is DBA's best friend.
там ограничения по сети,
So there are limitations of subnetworks and hosts. Even if your firewalls ensure good level of security, there is some sense to use PGHBA. There is some sense to provide certain privileges to those people who will go to the server. And authentication type can be defined at a user level too, or at the level of subnetworks. So this is the example. Not a typical PGHBA file. Why not typical? Because it's not an 1S server. It is integration server. And we use it for external systems and also for DBC protocol. So string number 1 is quite clear. This is local connection. Peer is the method of connection. Then pay attention to this moment. It is MD5. It's a kind of a local system, monitoring system with some limited rights. It runs on the same server, not on the domain account, and you can use the same authentication password. All servers that have access to it can use this account. If you need to administrate something, you are just using sudo Postgres. So this is the only super user. Other people can access, can connect if they have a special role. And this is the 1S Linux-based server, which is located in the same subnetwork. So we didn't do anything special with domain authentication, we're just using roles. And then we have this host, this subnetwork. It is a kind of machine where we write some operations. So what this is, you can check my last year's reports. I've got so many details about this. So check this out. You can understand how to work with it. So if you run Postgres on Windows, it's quite simple. It's too simple. Everything that is required from you is to run 1S Postgres SQL server onto domain account. Then it works just fine. You just write PGHBA file, you activate Kerberos, and everything works fine. With Linux, we have to find some workarounds. What Anton mentioned yesterday, that it is difficult to set PG Pro backup, it's just a piece of cake. It's much more difficult to set up Kerberos for Linux servers. Even if you do everything correctly, then you may find some problems. So you have an account in Active Directory, and there should be no critical servers inside this Active Directory. So you have to have a special thread for it, and you cannot use your enterprise name, because it will allow you to create this command created by our GitHub file. So this kind of command, it will be created, you will try to authenticate, it will say you failed, and unless you go to domain controller and sort things out, you will not understand what is happening. When you are running this command, so server name over here, it must be lowercase. No matter what is your server name, what is your real server name, what your host says, Postgres in uppercase, server in lowercase. And the same, you will create a file, you will try to authenticate, and you will get a fail error, and unless you go to domain controller, you will not understand what is going on. What comes next? It works with 1S server, but at the same time, it's absolutely not intuitive. How authentication looks like when it comes to 1S? You leave blank username and password fields. You go, and everything works. If you do it in this case, you will have an empty username, and authentication will not be possible. And it seemed that nothing could be done, but all you have to do is to indicate your username and then to leave the password field blank. Then this information will be passed to Postgres server. Authentication will be requested. So by using a special mechanism, this credential will be compared. If they match, the server will think that everything is okay. The connection will be established. You cannot use foreign credentials. So 1S doesn't know how to do it like MySQL, but if you do like as I said, everything will work. It's not obvious. And by the way, a lot of clients, a lot of Postgres and 1S clients do not allow you to leave password field empty, so you can use this trick. Sometimes it works. Now, what about architecture? So very basic things that developers sometimes forget. So you have to separate landscapes. So testing, production, development, they must be separated one from each other. You have to have minimum network access. You have Postgres server, and only 2 ports should be open. 5432 and SSH. That's it, nothing more. If you have production databases, you shouldn't have something like user 1S. Each system must be run under their corresponding account. And this account should be the owner of the database and all the clients. In Postgres, you can easily change an owner, by the way. And when you are updating production tests, don't forget to do reset count, because otherwise the owner will become a new person, but all objects will belong to production database. By using this approach, owner shouldn't have a super user. 1S will not allow you to create a super user, by the way. And database owner shouldn't have super user privileges. Otherwise, you will compromise a database, but only one database, not all databases. And please do not forget, but this doesn't apply to 1S, because such functions are not there. But by default, public role has execute privileges for all functions. If you have any functions that are being executed with the owner rights or caller rights, this is a very big hole in your security line. Otherwise, you have to do execute from public. So this is quite a dangerous moment. Okay, fault tolerance already mentioned. And now, so security is over. Now let's talk about fault tolerance. Okay. So as you know, all DBAs are divided into 2 groups: those who do backups, those who have never lost their data. Sometimes DBAs start to be paranoid, and they provide a fault tolerance level that just overlap everything. You got sync replication, 10 backups, but this is too much. So I will act as a manager right now, and I will take a different look at this task.
надо начинать
You always have to start your designing
того, что у вас система может, а не с того, что у вас есть аппарат какой-то. Волшебное слово.
with just two simple words, RTO and RPO, recovery time objective and a recovery point objective. First is the is acceptable time of recovery, and the second one is acceptable data losses. So only business users can tell you something about these two things.
Потому что вот если в этом
You don't have
есть люди, кто
to do more if they don't need it. If we take a look at this graph, you see,
такая штука получится сумма. Причем вот эта сумма
so,
огромная.
so these amounts, they are in dollars, in USD.
Который может допустить админ, сейчас вот эту
And sometimes DBAs think that we will do sync replication, everything is okay, and it's quite cheap. But if it is cheap, you might probably miss something, because sync replication is using traffic too much. Otherwise, commits will not be executed on time. If you have automated replica switchover, you have to consider the worst scenario. You need to think about the worst scenario. And these scenarios can be numerous. You have to sit down and make something like a brainstorm and think what can happen if this happens or that happens. And if you go beyond this line, you can't say business that we have those characteristics, because you will be asked what is guaranteed and why. So, maybe 5 minutes is okay, 5 minutes of downtime is okay, maybe 15 minutes of downtime is okay. Well, the price, your cost go down, and you ensure fault tolerance. Another very important moment, 1S is not just a database, but it's an application server too. It's a web server, it's a licensing server, and if one component fails, nobody cares that your database is still running. Your data are kept. But if one component fails, your entire system will not work. For example, if you change your licensing server, the system will not work. Or terminal server or web server. If just one tiny component like an interchange server fails, everything will stop working. So there is no sense. That's why I want to tell you what is 1S specifics. Yes, we've got 24/7 systems, but I don't believe that there are 1S systems that give you 5 nines, because some inavailability due to 1S specific reasons will happen. If you have only one server that you just set up once and forever, maybe this is the case. But just for your understanding, if you have 60 minutes per day, which is agreed for maintenance, you will not hit 5 nines. So data retention is quite important. Business is ready to wait for 5, 10 or 15 minutes of downtime, but they are not ready to lose some data that they got like 5, 10 or 15 minutes ago. So these are commercial accounts. They are ready to wait for 5 or 10 minutes, but they're not ready to lose data that they got within these 5 or 10 minutes. Problems start when you have a queue out of these oil transportation vehicles, or when you have railway cars and they're waiting for the oil, but you are dealing with the downtime. So the cost of such downtime, of course, goes up. Of course, if you have agreed everything, that systems will not be available within 60 minutes in weekend, or well, shifts change. That's okay. You can afford it. All you have to do is just to schedule it. And another one as specific, our business said we need some functionality. We tested everything. We run this on testing, in dev, in prod. You deploy it in prod, and something goes wrong, and you have to roll back.
Теперь чуть-чуть. Now a little bit how it was done at the infrastructure level. We practically have no hardware servers. Almost everything is virtualized. I wouldn't even call it private cloud. That's not really that level. But infrastructure as a service is more or less implemented. So that's what we are working with. So if there's some hardware failure, then we will use this data storage system that will recover it. As Anton said, we don't have a 100 gigabyte server, 50 bases, 50 virtual machines, so we don't do that. So we have as much resources as we need. And another good thing about the virtualization in this context, you've got, for example, a task. The business, the corporate wants to have more resources, so you need to go somewhere to buy more hardware. You have this whole slot with a lot of hardware. You're just requesting to add 2 more cores, 2 more CPUs, or 60 GBs of RAM, and then they do that. Any hardware failures are processed by hypervisors, so there is a blade tuner, then it moves to another hardware, and then your virtual machine is still running, no matter what. So even to come up with a situation when something happens in the hardware failure and the server went down, well, okay, theoretically it is possible. If you really want to have a complete fail-safe when you have 2 servers and there is a really fast channel of traffic between those, and then it's synchronization between them, and if one of that database falls, then the another one starts working instead, and then it still functions, but then the budget will be, so the amount of money, like at that graph, will be 8 digits in dollars, so you might imagine what kind of infrastructure this is. And 1S licensing is not the smallest part of it, because 33,000 users of 1S, 33,000 licenses, it's a lot of money. And if you need to move to all this, to transfer all these 33,000 licenses, if you want to have it backed up, then you will need to spend a lot of money. And then centralized system of backing up. As a DBA, you just know that as soon as your data is going there, then it's saved. There are other people responsible for that. They have their backup process. Maybe even physically they are copying this information. Usually it happens outside, and it allows you to solve the problem. For example, at the oil base, something happened, something switched off, you still have backup outside, external backup outside the site. And from the enterprise perspective, it works great. So when you recover the system, then you were bringing in data, so you're not losing any data, in commercial sensitive data. Now look, it's another Hollywood subject matter. Traditional solutions for Postgres, for 1S, you've got a virtual machine, it has a Postgres cluster, and then there is the base, as Anton said, so it's a really modest thing here. You can see in this picture, it could be hundreds of them. So it's easy to admin, to manage, it's easy to deploy, but this solution is wrong. Because, okay, resource competition is one thing. You can't divide which bases were, and it was discussed. So one base started making up problems, and then the whole cluster, then you were running out of cache, and everything gets stuck, or the performance is really low. The same for the backup process. with all the gratitude I have for Postgres Professional, for the pro backup, and for the possibility to recover one database, it still takes a lot of time. So scenario when you had a cluster, you were upgrading one database, then it went down, and you need to recover it exactly for the moment of the beginning of this update. Then you are doing PG dump, and it's taking a lot of time, and then it would take another 2 hours to recover it. I'm not even talking about TB basis, but even 200, 300 TBs, and at a good server using PGDump at the newer version, it's happening faster because they parallel the index creation. But while indexes were going in one flow, then it took 2-3 hours to recover it from the dump file. So, and then we are running over that 1 hour that we agreed upon. So we can solve it two ways. You can do it this way, you can do it that way. Both approaches have its pros and its cons, but these are good solutions. So either you have one virtual machine and you have different clusters for different ports with one productive database, or it is all completely virtual for one database. In this case, it is relatively easier to upgrade the software. So you are just starting the update command, and all the systems are updated. And if clusters are in different ports, you can switch them off, you can disable them independently. And these things, they can give you pretty good fail-safe feature and safety feature. So it's traditional for Oracle, this kind of approach, and it is more organic for Postgres. Now look how we did the fail-safe, the hottest subject matter currently. We did it hardcore. We are switching between servers manually. There is no automatic switching and no master replica switchover, automatical switchover. First of all, because we have 24/7 people on duty, engineers on duty, and if a server went down or froze, then people will look at it immediately. And secondly, 15 minutes they can handle this, so it's no problem to wait for 15 minutes. The situation when, well, just as an example, we had a situation when failsafe could have only made it worse. So we had a hypervisor, hardware failed, and it started to migrate, and then started to switch over. It went wrong, and then it switched off, and then it recovered again at a new physical host. So it didn't manage to transfer smoothly, and our master just switched off. If we use the automatic system and we switch to replica, then it seems that it would be fine. But then if the second one, if it was using the same hypervisor, it would also switch off. So if it's all isolated, then it still would work out in the end. But then again, how much money would we spend? Either we will need to go back, and I agree with Anton regarding that. If somehow your master failed, went down, so before engineer looks at it, you shouldn't really roll back to it. Maybe it was just everything might be going well. Maybe it was just it ran out of RAM, some 1S connected to something horrible. Then there was no memory available in the swap file, and your Postgres panicked and failed. So fatal panic, restart, and then it works again. But maybe something happened at the database center, and then you would be able to recover it, but it would be running some suspicious commands, so you better not. So if it's only one way, then you're risking that both of them will fail. If it's both ways, then you're risking to lose data. So if there is an engineer, so let him look at it and to switch it manually if there is a need. Then again, our failsafe is implemented this way. It's implemented the way that if we have some scheduled maintenance works, then any of these four machines, we can just switch them off using a script. In 1S, we are just taking out one of the working servers from the cluster, and it's still working. Here we will need to switch it. It's a typical situation, so some safety updates, something like that we need to do. and especially the server under Windows, and we have production systems with the Windows servers. If there is no much workload, then it could take 1 hour and a half to update the server. It comes, it starts to unpack, then they delete some cache files, and then it takes a lot of time, it works badly, and your system is unavailable, non-available. And here you can just switch between your machines manually. You can switch master to this machine. This server is working, is under maintenance. You see that everything is good, then you roll it back. Then the second scenario, you want to install some potentially risky update. So here your database will remain the way it was before the update. So you are updating, if everything goes well, you restarted it, and the replica is copying this data, it's fine. If something failed, then again you could switch to this one. It's a working system before the update moment of time, so you don't need to recover anything. So downtime is exactly the update time, the installation time, and then some time that you will need to switch between replicas. It takes just mere minutes and everything would be going well again. Now, backup. Again, PG Pro Backup is a great thing, is a wonderful thing on a number of reasons. First of all, it's archiving or differential backups. Great catalog, great folder. You can see what you got there, what is the moment of recovery. So, which are the times, the periods of time what you can back up to, roll back to. You can always validate as well. So these are all very useful. I don't know, do we have people from PG Pro here? So maybe you will tell them, oh, some bad business people, they don't want this interface for the backup, they want to integrate it with the corporate, with the enterprise systems. Then it would have been really good, would have been so good if you did that. So how do we do that? How do we solve this situation when there is no native integration? We just pre-exec, we use pre-exec and post-exec scripts. And pre-exec we make the full backup to some local catalog, local folder. Then our system is taking the backup, pressurized backup, packed backup, and then we have a local copy, and we have two of them when we're making a backup, the previous and the current. We made a backup, we know that it'll roll back to this, then we delete the previous one, and we still have the current one, and we want to recover something from the backup. The DBA, and we don't need engineers, backing up engineers. We can recover it. If you need to take something out of the archive, then usually they don't need it right here and right now. Sometimes we have some requests from the enterprise. We did something, we want to compare it with the state from the last month, give us the database from the last month. No problem, we can do that, but it will take some time. It will take a day, and they will wait a day, so because it always takes some time. And when you do that, please don't forget about this thing. Don't forget to exclude this thing, because that part is the wall that is currently writing the archive. And you might have a conflict of the separation of the accesses. The system will start swearing at you and cursing, so you shouldn't do that. So this file shouldn't be copied because it's unfinished. So you just create a mask of exceptions for these files, and then all walls are backed up on where you need it, and then you can recover it always. Now let's talk about standards. So how did we do that? Well, first of all, enterprise safety, security, of course. We don't have any exit to external repositories. We have an internal repository, our own. And there we have some common. So we have a lot of Postgres as standard, professional versions for this OS, for that OS. And if we need to install something, we're just taking it from there and we install it. And now, being a person who was kicked by Oracle, so I when I come to server, I know where the Postgres is. I don't need to remember about vol, about leap, about anything. It's always there. And that's it. And I know that. And usually that's a separate file system. So maybe there is some allocated disk that work faster. But I will go back to that later. Some security settings are also done in catalog. So the fail-safe requirements, I talked about RTO. We have a standard sheet where when we make servers, we have a schedule there, we have requirements, the depth of storage, so it's a standard sheet. And when we look at these files, we already know what we do, so what scenario should we follow. Now about scripts, we don't deploy with the ready-made machines. We have a server with the requirements we need from the infrastructure, then we enter there. We go there, and the script, I will just show you how it looks like, just as an example. So we have the Red Hat Bear server with volumes for Postgres allocated for everything that we need. And first it's sysctl-conf, standard settings, and you can see everything here, all these commands. And so we're using huge pages, among other things. Not that it improving performance that much, but just recently we have found, because of the fragmentation of memory, the Postgres was giving errors, giving warnings, issuing warnings because the memory was slowing down. And we took a look at the log, and then we just increased the memory because it couldn't couldn't handle huge pages, so we had to do that. So please make these checks whenever you are changing some settings regarding the memory in Postgres. Make sure that it fits cat prods, mem, gripe huge, and you will see it there if it's used or not. Then we have also changed that, so that's a human install that we install that went to our repository and then installed the Post Pro. Then we stop it there. Why do we do that? Because we have different folders, so we delete all this thing. We are creating mkdir, chmod, and everything that we might need there. We changed the user. We installed the home catalog that we are used to, that we are accustomed to. We put there this command, etc default, and vanilla Postgres is done a little bit differently, so that the catalog to put the path there, but everything is quite transparent as well in there. So again, we go to Postgres, go back to Postgres, we made our PG data, so that we always had it near whenever we need it. We have a bash profile, so when we exit and we restart to start all these processes, so then checksums right away, we're entering here the local P, host MD5, catalog, local. Without too much troubles, we are putting here all the hosts that we need to access. And the difference here, PostgreSQL, we are just changing 3 settings, these ones. And the next one here, so right away we took it and we created the RAM disk, so with 2 commands, so we write it, we mounted it, that's it, we start. After we start, we go there, we enter, and we have this whole sheet altered database, and we just apply all the settings. All the settings from Alta database is going to SQL Dataconf, and then I can see right away what I changed there. And another advantage of this system, it's not going to issue any errors. It will not allow you to put any wrong value, any wrong definition there. So if you forgot about something, and then it wouldn't start. If you did some mistake, made some mistake, it wouldn't allow you to put in invalid value. And then it will just start issuing, giving you errors, showing errors. Now about the Windows specifics. The first thing that we've talked about the old installers and the new ones have it. They have a checkbox of advanced options. You can go there and you can change the the user account, and so the Kerberos could work with that. This important thing. So if you have some antivirus software like our Kaspersky does horrible things to Postgres. We had a situation when it found some signature and then it put a file into quarantine, and the whole cluster then just failed and went down just like that. Don't do that. So that's a must. This PG cluster must always be an exceptions. RAM disk, there is a standard Windows solution on creating RAM disk. So no external software, you don't need anything. You have the script in the target program. So if you need it, I can send you how it's done. So that's no difficult. Just Google this command. So there is a number of commands. You just need to create it. You just need to start it, give it the size, allocate some letters, and then that's it. And then you will need to change the startup type to delayed start, because there is a chance that if your Postgres just stopped on schedule, not because hardware failed, it's going to start earlier than your RAM disk will be created. And then start TMP will say there is no stat TMP, and even after it's created, wouldn't start. It will just go down when it starts, so which is not a good thing. So if you put a delayed start, it will wait for a number of minutes, then it will have time to deploy the RAM disk, and then it'll be fine. So now let's pause for a while, make a little break. That's the first large chunk where I told you how it all was done. In our case, I'm not saying that that's a perfect solution, that it works all the time, but it does work, so it makes the enterprises happy, and we have experience to prove it. We have a 24/7 system at the oil sites with high workloads, and it's been done using Postgres and the problems that I told you about. So these are real-life problems, and that was the solution that we found, that we came up with, and we also divided it for the two oil refining factories. The Moscow factory, Omsk factory, they both have this system that is sending away these oil trucks or trains from their station, and that's how they work with databases. And we always come to the problem that there are a lot of integration schemes and systems, even if you have a perfect failsafe at the database level, but if you integrate with the tram and the Russian railway system fails, then who cares that your system works? You wouldn't be able to send a single train car. And then again, about the comparison, a couple of words, because it was announced in the title and the description. So when you work with MS, so the first thing, it's much better when everything is perfectly working with the backup system. So it connects to MS SQL, gets backup from there. You send query to sysbackup history, and you can see the list of all the backups, and they have this large ID, and your ribbon understands it, and at least you can see that you've got it, and they're stored there, and it's a good thing, it's a useful thing. If PG broke backup, we'll learn how to do that. That would be just awesome. And the backup of separate databases is also clear about the compatibility, so I can talk about that. If you have some older versions of 1S, older configuration that were made for MS SQL, it will be quite hard to migrate them to Postgres. Now about the good things, this magic command, in some situations, it could really help you out, could really sell you. For example, you've got a database, 95% of this is the table with the scanned documents. If you do it with MS SQL, with backup and restore, how do you do that? You are making a backup. Let's say, anyhow, you're making a backup. Then you restore it to a task base. Then you make a truncate base, takes you 1 hour. Then you give a command shrink database, and then 12 hours your base will shrink. Yes, user can access it, but your data center is going to look like that because it shrinks the base. And if you're not doing that, then you can, one answers the like test things, and it's a good thing, but you might have 10 test bases for one database, and your base is hundreds of GBs or a TB, well, I mean 1 TB or like something. And if you multiply it all, then no one is going you to give so many fast disks for a test server. So we have to shrink it, and shrinking is pain. And in Postgres, you can enter this magic command, exclude table data, and this large table of yours, it will come with all the indexes, with all the metadata, but it will not contain any data. And right away, you will have this small and neat database, which is good. But if you really want it using integration servers of MS SQL, you can make an analog of this, but it will only work until you update your configuration, because the list of tables will change and you will have to do all this work again. And again, reindexation, update statistics before the end of month, it also usually takes about 20 hours, if not more. And here you can do it on the fly. The same with this vacuum full, so you deleted some historical data, some large data, big data, and you will need to shrink your databases, and in this case, in fraction of just 2 times as fast, you can clean one table and you will feel fine. And that's the file I've been talking about.
So just a few words more. So when you can migrate, when it is easy, when it is not. If you've got a new ERP, you can easily migrate from MS SQL to PostgreSQL. If you have old ERP, you will have to do some work, very serious work, because it is very likely that some reports can crash on Postgres once you migrate to it. You will have to find problems, you have to rewrite code, you will have to test and test and test. And last but not least, your performance will be better than if you migrate from MS SQL Server 2018 to 2016. But sometimes there can be some performance degradation in very unusual places. And also, it is better not to use old configurations. And that's it from my side. I think we don't have... So we've got 5 minutes for questions. Okay, here we go. So my question is on monitoring and backup monitoring in particular. How do you check it? So we are using SRK, and last time I mentioned this, we have one single centralized monitoring center. So if backup goes to that center, it's okay. It means that PG Pro backup was done, and backup engineer sees this information. If something fails, you will get a call from him. So another question. Have you ever restored high-load databases out of backup? Yes, we have, and this situation happened when our configuration crashed. 2 hours of downtime. We had to restore the database out of backup. So you done full backup. So back in the days, we didn't have any replicas. If we had replica, so we would have avoided such a situation. But that was such a pain. And there was another situation when business people asked for data from 1 month ago, and in that case we had to restore from full backup. We made a dump of the database that they required. Then we loaded everything and everything was okay. Well, I think this topic is quite interesting, and I think that the rest of the questions can be discussed offline. I know that we're working on backups, and I fixed information on what you have said, and let's give a round of applause to our speaker.